Question 12 is combination of arithmetic and geometric series. A checkboard measures 8 squares by 8 squares with adjacent squares alternating in color. Dave places 1 penny on the first white square, 101 pennies on the second white square, and so on, increasing the number of pennies by 100 on subsequent squares. He then places 1 penny on the first black square, 2 on the second black square, and so on, doubling the number of pennies on the subsequent squares. Dave completely covers all white and black squares. Calculate total money on the checkboard. Determine when the total number of pennies on the black squares would exceed the total number of pennies on the white square. Okay, now this is a simple problem. Here the only thing is, it's a practice for you to find sum of arithmetic sequence terms and sum of geometric sequence terms. In the arithmetic sequence terms, the first number is 1 and the D is 100, right? Because you are adding 100 each time and number of squares will be divided equally between the two colors. So 32 for black and 32 for white, right? So here is a formula for sum of n terms for arithmetic sequence. Here we know A is 1, correct? And D is 100 and n equals to 32. So plug in these values and calculate your answer. For geometric sequence, the formula is Sn equals to A times r to the power of n minus 1 divided by r minus 1. And here what is A? A is just 1 for you and r is 2. You're doubling each time, right? R equals to 2 and n is 32. So when you plug these values in, then you can find the sum, right? And to do the second part, you need to equate the two equations and then figure out when will this be higher. You can do trial and error also. Okay, so try the method which you find easier and figure out the answers, correct? I hope that should be fun. It's not difficult, so I'm not doing the calculation part for you. Thank you.